In this presentation, we present the CTAF concept, an electric traction chain with segmented power supply. With the development of the electric vehicle, the traction chains are being more and more integrated. This is because it will enable a significant reduction in costs, size, weight, and losses. In this context, we propose the concept CTAF. To illustrate the concept, we consider this traction chain. The machine is generic, the topology of the rotor is not specified. The two-pole, three-phase electrical machine has concentrated armature windings. There are 3 stator windings and therefore 6 terminals. The windings are star connected. Each winding is made of 2 series connected coils. Each coil has 3 turns and is wound around a different tooth. The machine is fed by a 3-phase power converter having a DC side voltage VDC. It is possible to segment the power supply by splitting the windings into sub-windings. The conventional way is to split the windings by coil. For example, the winding A is split into A1 and A2. As a result, there are 6 sub-windings and therefore 12 terminals. Each sub-winding is now made of a single coil. Note that each sub-winding is wound around a different tooth. To obtain the same magnetic state, the machine is now fed by 2 independent 3-phase converters having a DC side voltage VDC by 2. Such splitting has already been reported in the literature. For example, Wang split the stator into 3-phase blocks, each block being fed by its own 3-phase converter. We also find this idea with the smart stator tooth of the Emil project. Such splitting enables to add redundancy to the drive and/or to adapt the voltage ratings of the machine and the power electronics. The original idea proposed here is to go further and to split the windings by bundle of turns. For example, the subwinding A1 is split into A11, A12, and A13. As a result, there are 18 subwindings and therefore 36 terminals. Each subwinding is now made of a single turn. Note that several subwindings are now wound around the same tooth. To obtain the same magnetic state, the machine is now fed by 6 independent 3-phase converters having a DC side voltage of VDC by 6. The proposed concept does not necessarily imply to split the windings up to the turn. This is only one option among others. Finally, we underline that the concept equally applies to machines with distributed windings. We list here the advantages and drawbacks of the concept. They are discussed in detail in the article. The main advantage is the possibility to operate the DC bus at reduced voltage compared to the equivalent standard solution. At the same time, the availability rate is improved by the choice of a multi-converter architecture. On the other hand, a large number of sensors is required. This adds to the difficulty of synchronization that could lead to the need to resync the control. The collaboration started in 2016. We drafted a patent and built a machine with split windings. In 2017, a task force was formed. Working sessions were organized to define the scientific project. In parallel, we built a segmented power converter with 3 independent 2-level VSC. In 2019, a first PhD thesis started. The machine with split windings and the segmented power converter were assembled to obtain a proof of concept. As a conclusion, we list here the scientific and technical obstacles on which it is necessary to work in order to develop the concept CTAF. Modeling of the traction chain, implementation of the hierarchical control in LC and degraded mode, analysis of the degrees of freedom offered for auxiliary functions, study of the impact of the design and quality of the connections and sensors, and finally, co-optimization of the converter machine and eco-design.